Hello, everyone, and welcome to Onshape Live, and this track in particular, which is the advanced surfacing track. And let me just get it shared properly here. Advanced surfacing track, insights from Trek. So my name's Tim Freeze. Joining me is David Showfield. Also, Jenny Johnson will be joining us as well. She is moderating the moderated Q&A. So you guys will have two areas over to your right, I believe, where you can have a chat to talk amongst yourselves. And there also is a moderated QA section where you can start to put in questions that we will address at the end of the session, right? So let's go through a little bit of agenda. So we'll start with a little bit of complex surfacing philosophy and mindset. So like I said, joining me today will be David Showfield from Trek Bicycles. And that will be his part of the presentation. He'll go through some of those philosophies and mindsets that he has accrued over his years, and is really kind of an extension of the Trek philosophy and mindset as well. I'll then go into some surfacing tips inside of Onshape that kind of go along with that mindset and philosophy. I'll cover a little bit. Onshape is an ecosystem. So I'll cover a little bit of some info from that ecosystem at the end, particularly maybe a partner product in particular. And then we'll have our QA session. Okay. So just a little bit about me. My name is Tim Freeze. I am currently the Senior Manager of Enterprise Technical Services here at Onshape PTC. Been here more than 5 years, was here when Onshape was still a startup, right? I did start my career in industry before moving on to the reseller networks as a senior applications engineer, and then finally here to Onshape. Okay, so I'll let David go ahead and introduce himself.
All right, thank you, Tim. Appreciate it. Really happy to be here with everyone today, and really excited that Onshape asked me to speak at this event and share some of my knowledge as it relates to 3D CAD and surfacing. And so this will be really kind of a philosophy and mindset approach. I've sat through many different CAD webinars and 3D CAD classes, and I really tried to take a unique approach to this and maybe put this together how I would have liked someone to talk to me 10 or 15 years ago when I started this journey of advanced 3D CAD and surfacing. So that's what we'll look at today. So yeah, I've been at Trek since 2010, worked on a lot of helmets and really helped put together that helmet development at Trek. And prior to that, I was in the motorcycle industry for about 5 years. So this is the philosophy and mindset, kind of the list of the concepts that I want to walk through. I'm not going to read each of these because we'll spend a little bit of time on each of these pages. So we'll just get right into it. First one is design history. Something I like to think about often is the fact that product design and industrial design and engineering has been around a lot longer than computers and CAD systems. And so, in some ways we are standing on the shoulders of some of those giants and other things that came before us. And so as far as the history goes, I don't mean that we go back in time and do it the way that we used to do it. But conversely, we also shouldn't move forward and completely forget about the past. I think there are things that were done in the past before computers that we would be really well served to think about some of those things and figure out how we can incorporate those into current processes. And I'll talk about some of those things in later slides. So the next concept, CAD is a tool. At the end of the day, that's exactly what it is, and it needs to be operated by someone. And, I put here that CAD is fun. I think back to, I was lucky enough way back in high school to actually work on that was my first experience with a 3D CAD system. And I remember that first time that there was a profile drawn and then it extruded to a 3D shape. It was probably a cube with a hole through it. But the excitement of being able to rotate that around and see what looked like a real object, that passion and excitement has never gone away. Working up to parts like this one on my screen. Most of the screenshots you'll see today are things from motorcycle industry, parts and accessories, things I've created at Trek, accessories and helmets and such.
Yeah, that's key to note. All the designs you'll see on David's slides were designed by him. So
so here is a title to a chapter that we'll probably never see, in a YouTube video or a book about CAD or a help section, which is, here's the best approach to make an awesome, efficient, robust, aesthetically pleasing, and nearly perfect model. And the reason is because I don't think, excuse me, there is one approach to that. There is no one size fits all. It really is a unique type of system. Excuse me for 1 second. Where there's more than one way to, approach a model, and we should never limit it to, it needs to be done like this and that's it. There are different approaches to the same result. Certainly there's best practices and, best approaches to things, but there's not really one size that fits all to modeling in CAD. Next slide.
Everybody designs, everybody CADs differently, right? That's kind of an old adage.
Next up, the easy button. So there is no big shiny magic easy button in CAD. I've worked on many different CAD systems, and there's so many cool features in many, if not all of them, things to help us, make our job easier or to automate, a certain, feature that we want to create. But, ultimately, things a lot of times need to be created from a blank space. This model on the screen here, the screenshot, the only thing that existed when this project began was at the bottom of the screen. If you see those, the 4 holes there, where this fairing bracket mounts to a frame, that was the only thing that existed. Nothing else existed. So everything had to be created with myself working with industrial design and analysis. And it was a really cool journey to get to this part, but everything had to be created, from scratch. So next. And, speaking of a part like that, here's something that I try to remind myself about, is the fact that, the customer, whatever industry you're in, it's important to remember that really the customer probably doesn't care what CAD system was used to create the product. Now, that doesn't mean that we're not excited about that, or we shouldn't care about that. Most of the people here that are users or industries who use CAD or are using Onshape, of course, we care about the tool, but the customer doesn't. And so if we go to the next slide, I will touch on how that's important. And here's one example. A question that I have to ask myself regularly is, are we in the business of making a perfect 3D CAD model, or is it really about delivering better and more innovative products or solutions? And I think it's pretty safe to say that the majority of us believe it is the latter, and it's not making perfect 3D CAD models. Next. And here's something that kind of ties into that perspective. So there was a quote by Dr. Ian Malcolm, who said, "But your scientists were so preoccupied with whether or not they could, that they didn't stop to think if they should. Dr. Ian Malcolm, if you'll remember, maybe you don't, is Jeff Goldblum's character in Jurassic Park, right? The leather jacket wearing rock star scientist.
Great movie.
Great movie. Lots of 3D and special effects put into that. But he was referring to, hey, should we have brought, dinosaurs, back to life or not? So how am I going to apply this to 3D CAD? Well, here's my thinking is with CAD systems, we have a lot of functionality and a lot of power to do a lot of different types of analysis. Here's one example, the zoom. Being able to zoom in to a part well beyond what the manufacturing tolerances of that part that you're working on. So it's all about just keeping things in perspective, in that I've made this mistake myself so many times, which is I'm really focused on fixing this tiny surface or this tiny curve that has a kink in it. And I am zoomed in well beyond the manufacturing tolerance. So there is wasted energy because that's going to get washed away in the process anyway. So it doesn't mean that we forget about all of that, but I think it's more about bucketing. So if you look at the picture of this bicycle helmet, here's one where with the A side surfaces or the show side, of course, we're really concerned with those, and I'm going to pay special attention to those. But what about areas like under the visor or inside of the helmet where there's small fillets or small chamfers or radii that no one is ever going to look at, no one's ever going to see? It's not going to affect the robustness of the part. Those are things inside to move on quickly and focus on the things that matter. So perspective. This next concept of visualizing it is really important, especially for advanced 3D CAD. And this is not something I knew or realized as how important it was earlier in my career. And it usually with advanced surfacing, advanced 3D, we're either starting from nothing, which is maybe just a sketch on paper, or in maybe a very early CAD model. Maybe we only have the physical object itself or something we're going to reference. And so I say, here the importance of planning out like what the change is going to be or what it's going to look like before you just start tearing into the CAD model, because again, I've done this before where I just want to get into the CAD, make the change and get it done. But that might not be the best approach. Sometimes you need to visualize what you're going to do before you actually start doing it. So I say, get yourself or help yourself or get yourself help. And so what I mean by that is if you need to take a screenshot and draw where you're going to make the change, you could do that. If you actually have a physical part, Play-Doh or clay, stick it on the part and maybe shape it out of what it might look like. If your part is something different where you could shape it with paper or cardboard, do that, things you could do really quickly. If you're the type of person that you can do 3D CAD, but you just can't visualize it, that's still okay, because I'm pretty sure that you probably have help, which is most likely in the form of industrial design. So ask them to get you those things. Say, hey, I can't visualize what this change is going to look like. Can you get me a sketch or an early mock-up 3D CAD model? Because once you have that visual reference, most of us now probably have two screens. I always have that visual reference on the left screen, or if it's a physical sample, sitting on my lap. It's so helpful to have that, because then you're doing your 3D CAD and you have something to go back and constantly reference. Really important. This next concept, I kind of came up with this acronym myself years ago when I was working on some really complicated CAD models. Actually, not this one, but I needed a way to convince myself that, hey, I can do this. And so the acronym is places. So points, lines, arcs, curves, edges, surfaces. And then if you go to the next slide, I've simplified that to places where I've taken out the arc and the edges, because arcs are kind of curves and edges are curves or lines anyway. And so this was a way of patting myself on the back or consoling myself to say, hey, don't worry about it. You can do this. At the end of the day, this advanced 3D model, no matter what you do, it's going to be made up of points, lines, curves, and surfaces. And that was a way of trying to keep it simple, in my mind, even if it's a complex model, approach it with a simple mentality. Next screen, or next slide. Couple slides here on really more of things that are important no matter what industry you're in. So the first one is a no drama zone. Drama is great in a Netflix series, probably unavoidable if you have teenagers at home, but at the workplace, and specifically with CAD, it's just, there's no place for drama. It's not going to help anyone. So let me apply this to 3D CAD and modeling. Let's say that I get a model that someone else worked on, and it is just created in a way that I wouldn't create it, or maybe I disagree with what the change is going to be. The most important thing is to really just focus on it as solving that problem and getting it done, and not getting caught up in the drama of things. Now, that doesn't mean that there's not things that might need to be addressed, but I say here, that if there is drama in the workplace or with the CAD model or on your team, or a relationship between engineering and insert other group here, just take the right path to resolving. I mean, it's definitely a teamwork thing, and coming up with those partners to get those things resolved. It's always the best way is to avoid drama. And the next slide here, which really ties into the no drama zone, is attitude. I've always tried to do this, the best that I can, which is to remain optimistic. And I mentioned early on how 3D CAD I've always enjoyed it, and that it's fun, and that it's a positive attitude goes such a long way with something like this. If it's something that you love doing. And something I'll touch on here with this as far as the attitude goes is not getting too emotionally attached to a model that you're working on. And again, I'll say this again. I've had models that I've worked on for whether it was days, or weeks, and you become attached to it. I mean, that model is your baby. But then it goes, at some point, there's an iteration that has to go out to a supplier or to quality or analysis or ID or product. And there's going to be feedback, coming in from all these different sources. And the most important thing is really, teamwork makes the dream work, I think, is the best mentality there, which is don't have to get caught up or emotional about a change that's asked, on the part, is that it's really a collective thing. And 3D CAD modeling is super cool because, and I was thinking about this morning when I was practicing these slides, which is there's not many other products or files within a workplace that do so much before it actually becomes a product, so that you have this visual representation on your screen that you're able to get prototypes printed, have analysis look at it, send it to product, send it to marketing. And it's the little engine that it does so many things, and it's something to be proud of. And again, if you can remove the emotion from it and focus on, hey, this is going to, solve a lot of problems early on, and it's going to help make up this awesome product. That's really cool. And I believe, yeah, so my last slide here is, I've got another movie reference here. So, when it comes to learning and getting good at 3D CAD or advanced 3D, advanced surfacing, unfortunately, there is no matrix style, download to Neil's brain. I know Kung Fu, or, I know advanced surfacing. It's all about practice. I tried to get better, quicker at it. And when I think back, it was all of just going through it several times to get better at it. And that doesn't mean that all hope is lost, that there aren't, there are great resources out there. There's books, there's YouTube, of course. And then a couple little tips that I will give here. If you're looking, to get better or refine, your skills in surfacing, grabbing parts around your house that aren't related to something work related that you can just model up. I mean, a water bottle, whatever it is, to grab something, and don't worry about the measurements of it or the exact size. Just model it. Just make it look like whatever it is. And that is a pretty fast track to learning advanced CAD pretty quickly. And with that, I want to, thank Onshape and Tim again for this opportunity. I really appreciate it. And I will turn it over to Tim.
Awesome. Thank you, David. I appreciate it as well. And remember, we'll have QA at the end. So if you have any questions for David and kind of these philosophies that he's talked about, we can post them in the QA and get you some answers, hopefully. So, all right. So I'm going to jump into my section. And what I wanted to do was I wanted to connect my section with David's, right? So I wanted to maybe give a couple of tips that you can do inside of Onshape that kind of reinforces it, what he was talking about, right? And kind of this first one is just, for some of these advanced surfacings, and a lot of these tips were used at Trek, right? In their usage of Onshape. The first one here is just layouts, right? So when Trek makes a frame, there is somewhat of a center line that is similar to all their frames that they've used their magic sauce and developed, these measurements for their frame sizes, right? So connecting back to David's, making something robust and using his places reference, right? Lines, arcs, planes, right? Having that bone structure and having that inside of Onshape or inside your design is only going to help you. Okay. So I'm going to actually jump over and I'm going to open a few things here in Onshape. So I'm going to open probably everything, and then I'll just I'll concentrate on the layout first, right? So like I said, with Trek, the approach we took with this frame was kind of this repeatable process. So these layouts can have a reusable section, right? And they can have, what is specific, or they can be expanded upon to what is specific for this particular design, right? So I can basically have this reusable starting point that has built-in centerline geometries and starting planes that are all configured based off kind of that research and that secret sauce of, hey, a size 52 frame, these are the dimensions that are needed. A size 56 frame, these are the dimensions that are needed. So when I'm making any frame, I can start from these center lines, right? And I have some starting planes that go along with it, right? And when I do use this building block, or this is something that I copy or derive in, I can then set it to my size, right? So if I'm making a 62, or if I'm making, let's say I was making a 56, I have these starting points. Now, if I'm working on this particular one happens to be a certain type of frame, then I can expand upon this kind of template, right? So I can build in the kind of standard pieces that are unique to this frame, right? So for this frame, we're going to use these common derailleur and wheel points, right? We have a common hub set size, right? We got a common head tube size. All this stuff can be built in, and I can then build in my common, my common profile sketches and my common, planes for how I'm going to do these lofts and put these pieces together. Okay. And even if this, right, within this frame family, I'm going to make multiple sizes. So I could, again, kind of build that into my configurations as well. That way, when I go, I can build the 56, and when I go into then do maybe the 62, even this stuff follows along and kind of gives me those building blocks, right? So I have that kind of reusable across frame families, and then I have unique to this frame family, but it's all in effort of a layout that's going to help me at the end of the day. Okay. Next little piece here I want to use that was used on the Trek side as well. So I have a simple example, and then I'll show you the Trek example. Is just using guides, right? Guides give a lot more control in your surfaces. Okay, so if I go through the simple example here, let's go to my fill guides here. Just a basic bare bones example, just to kind of get the point across, particularly with fill in this case. So if I'm doing a fill and I just give it a profile, it's just going to give me a flat surface, right? But guides can actually add more control to this. And you can use different guides for different results, right? So if I can use points as a guide. So I can turn on my guides, I give it a point, I'm going to get a certain result, right? And as I add points, I'm going to change that result. So I can come in here and get a desired shape from just points, or I can use a curve and have different results, right? So if I turn off my guides, let's turn it back on. Let's clear them out. If I use this curve now, actually, let's do this as sampled at first, and then we'll kind of kick this down to 2. Now, if I give it a guide, it's going to kind of sample. With sample, it's going to pick 2 points. So essentially, it's going to pick the endpoints in this case, and I'm going to end up with a flat, right? But as I kick up that sample, right, so as I get to 3, it's going to kind of equally sample the curve that I'm doing, right? So if I jump up to about 5, it's going to get close. I get to 6, it's just going to keep going. So you get these little, and it's probably hard to see on the screen, but you have these little pink points. Now, I could play with the sample, or if I want to adhere to that curve directly, I can actually just pick precise, and it's going to actually use that curve for that weight, right? So that's just a very simplistic example. But if we go into my Trek frame in particular here, where this was used in practice on this frame, and this is an Amanda frame from Trek, is complex surfaces like this one here, right? So if you look at, and I'll show it to you, but if you look at, this is the same surface here. This surface is actually this one, sorry. Let's go ahead and edit that. So this surface relies on a couple of guides, right? It's relying on a guide from sketch 117 here and sketch 118, right? So I have my 2 guides. They're actually giving this surface its shape in a very tight transitional area, right? This is a pretty tough shape to get in here. And to tell you what, without these guides, the fill doesn't even complete, right? The fill will fail without these guides. So even in situations where a standard fill won't complete, guides can take you a long way and actually get you the desired result and get you a result, right? So guides are very powerful with the fill feature and using in your features in general, right? Even in a loft, you can have guides propagated there too. Okay. So my next little trip here is just on that. So match connections is another recent thing in loft as well. So using match connections, right, is kind of giving you more control. This particular surface here, we can see there's a, this is just a straight loft, right? And you can see there's a nice little like pinch in this surface. So guides can actually help you get rid of things like this in these little pinches. So if I come in here, I can then turn on my match connections. Sorry, not guides, but match connections. And I can then begin to give it points along the edge. So I can pick an actual point. I got to change my selection set. Sorry about that. Right there. So I can pick an actual point, or I can just pick randomly on an edge itself. Right. So that's going to now give me a place where I can adjust. And if you look at the kind of grid lines here, I can kind of evolve this pinch point, right? So I can kind of straighten out these curves and flatten out that pinch point to get a more nicer result. Okay. Want to make sure we leave enough time for questions, and so I'm burning along here. So another part of what David talked about was that aesthetically pleasing. At the end of the day, specifically for Trek, these frames are going to be highly reflective. I mean, they're painting these in automotive paint, right? So they want to constantly check their quality and continuity. And in advanced surfacing, it's a good idea to do that, especially when you want that aesthetically pleasing model, right? So there are a couple of additions inside of Onshape that have been made. One is the Curvature Combs, which you can kind of turn on and show your curvature combs. The other one is been around for a while, but we just kind of added to it with some more ability. Right. So if I jump over to, let's go to this one here. Basically, if I want to check my curvature on my surface here, I can right click, I can show my curvature. And now my curvature combs expand to my surface. Now, we've always had combs inside of Onshape, but it's only been in 2D curves or in our curves in nature in general, right? But now we can expand them to surfaces. And we can even check them. We can extend them across faces. Maybe I want to shut off my U curves there and extend across face just to see how it propagates. Can change the comb size and change the number of combs. Or maybe I just want to grab that other surface and have combs for both, right? So checking your curvatures there. And of course, you know, like I mentioned, the zebra stripes to check what's going on there. So maybe we'll go back here like we had in the picture. Maybe we want to check some continuity back here. We can turn on that curvature visualization. And another thing that's updated here is sometimes these surface edges get in the way of seeing these transitions. So what we can actually do now is turn off those edges and get a better idea what's going on. Or maybe I want to flip the stripes to get a different type of view for my stripes in these areas, right? So always a good idea to check your quality, your surface quality and controls. Now, another new thing in Onshape that people might not immediately think of to be able to do that and test the, you know, look at the quality, look at the continuity, is actually Render Studio. I mean, Render Studio, we're going to be adding light effects. We're going to be adding that paint, adding that reflectivity, and that's a good way to check your continuity, right? So I'll quickly jump over to this as well. Let's cancel that, and let's get some stuff in my way here. So apologize. I know we're getting close to time here. Let's go there and let's go over to Render Studio. So now within Onshape, we can actually jump into a Render Studio, right? We now have this Create Render Studio. And like I said, this is a great place to go ahead and check check your surfaces, continuities, and things of that nature. Okay. So I just have a scene here. So you can see, even if you're not actually creating a render, you can kind of come in here and check your reflections, right? You can apply different environments, like outside environments with lighting effects, and apply your paints. And I don't need this rendering for any sort of marketing picture. I'm just using it to check my surface quality. Okay. All right, before we jump into questions, I just want to cover that last cat add section. So if you are looking for a different type of tool, more of a non-parametric push-pull type of thing, we do have the Onshape ecosystem that goes into a particular product here called Phi. So I'll just briefly mention it and then we'll jump into QA. So it is in the App Store. like I said, it's not necessarily a NURBS based or anything like that. It's something different, right? It's not T-spline, it's not sub D either. It's actual curves and actual surfaces, and you're manipulating the curves to get those surfaces. So if you're looking for something like that, it works right inside of Onshape, like a lot of our apps do, and it is associative. Okay. All right. So with that, I'm sorry we went a little bit over, but with that, we'll jump into some questions here. So I'm going to ask my colleague Jenny if we have any questions that have popped up, and to go ahead and ask those.
We do. Can you hear me okay?
We can.
Perfect. All right. So we have a couple of questions that have come in. First one was for Dave during his section, was how much of Trek and its supply chain is using Onshape, his understanding that most of the bike industry is using Creo.
Well, Trek used to use a different CAD system. And we have been, I mean, how long have we been partnered with you, Tim?
Publicly or non-publicly?
Yeah.
So I in particular, I have held a technical relationship with Trek, and I think we're 3 years plus right now into the Trek relationship.
So the Onshape is relatively new to Trek publicly, but the relationship has been there, a while. And I'll just say, a big, kudos and tip of the cap to Onshape for being, the first that is fully in the cloud, because that has its challenges, without a doubt. But it is something that is going to be the future. And it has been, really cool to see where Onshape has come from and where they're taking the product.
Yeah, I think if I can add some color to just that relationship, that so there are active. So I mean, you don't just, and we say this with all our enterprise customers, Trek included, and Garrett, who's another huge customer, is and nobody does this. Nobody changes CAD overnight, right? So Onshape is very much a production product within Trek, but they do still have other production going on with other CAD tools, right? Just because you can't get rid of something overnight, and it's a typical migration when you talk about CAD, right? So Onshape is actively being used on production today in Trek. So I don't know if that answers the question, but
hopefully Simon will let me know if it doesn't.
Yeah.
So next question, when you're thinking about offset surfaces, is the customer asked, sometimes they use this command, but it forms a bad surface depending on the complexity. How do you know when to offset and when you can't offset? Is there a guideline?
Yeah, I wouldn't say I have a guideline. David, I don't know if you have a guideline, but I'll let you answer first if you have an answer. But
well, yeah, my short answer is I'm always going to try offset first, and hopefully it offsets. And if it doesn't, that one little trick you can try is the amount that you're offsetting. But frequently you're tied into that. I mean, if it's going to be a certain thickness of part or whatever it is, you need it to offset at that. And if it doesn't, then it goes back to the integrity of the surface that you're trying to offset. And so the first thing I would look at is the curves, the trim curves that make up that surface. And one good rule of thumb in advanced surfacing is to build your surface out a little bit further than you actually want it, and then trim in from that. Because if you build the beginning surface where if you untrim it and it doesn't untrim at all, because the extent of it, that's the whole universe that it knows, that a lot of times that's where a problem will come in with offset, because when it does offset, it wants that other surface to live outside of that trim surface. So if I want a surface this big, I'm going to start with it this big and then trim it. Tim, what are your thoughts?
Yeah, I was going to say the same thing. I mean, I find a lot with surfacing, it's not always exact, right? So each surface, each design is different. And like you said, I'll always try offset as well first. There are some tools in Onshape we could do. I mean, you could do an offset 0 and then a transform, and so there are some things other things you could do, but I'll usually try offset first. And a lot of things, like when we were talking about your section, just sometimes, to get to the surface you need, you have to build like a different surface and then blow that away to get you certain edges and then build that surface. And I think it all kind of falls in line with that. Sometimes I'll start with an offset, and then later down the line, I don't like that offset, and I'll kind of blow it away and do its own thing, right? Maybe I'm leveraging, like you said, maybe it's offset of something bigger. I'm trimming back those edges. Now I have edges, I can blow that away and kind of fill in my cleaner surface or something like that, right? So it's situational, of course, but that's kind of like my philosophy on it.
Perfect. David, this is a question. I'm not sure if this will make sense to you, but you said, how do you answer the question how if you can't answer why? It was on reference to one of your particular slides.
Yeah, so to expand on that, of course, the why is really important. And what I meant was that I didn't expand on very well is that not to get caught up on it. So if I'm starting a project or a modification to something, and of course, the first thing I would like the overview of, like, so why exactly are we doing this? And if it's something that maybe I don't exactly understand or agree with, seek those answers, but get to them quickly. Because, my point is that with, advanced 3D CAD and modeling, you're always trying to get to a buttoned up CAD model so that you can kind of stamp, okay, here we're at this iteration, here's where it is, because it's not until you have that you can make the decision for, the next step. So yeah, the why is important, but it's really, my point was that, just don't get completely caught up on it. Just try to focus on, how am I going to get to that point of what the next vision is for the next version of that model.
Perfect. Tim, could you provide any tips related to patching holes in surfaces for folks who are new to surfacing?
Yeah, I mean, patching holes in surfaces, you're going to have edges there, right? So fill is a great tool to do that. And fill you can even use with certain continuity choices. So position will just do that. It'll just be positioned to those edges, those hole edges. We also have tangency. We'll also have curvature continuous. So fill is going to be probably your tool of choice there. One thing I'll say too, and David touched upon this, is just learning resources for getting help. The Onshape Learning Center is there's a ton in it, right? There's beginning surfacing and there is advanced surfacing courses and techniques and videos inside the Learning Center, right? And you can get to it right from Onshape. So I would say if you're just learning surfacing, or even if you're an advanced surfacer, there are some learning materials in there that should teach you something, right? So there's a lot of stuff in there.
And we update that content constantly. I have a couple on my list.
Jenny's updating it right now. So
I have a couple of them. Curious of the best export options that are robust for surfaces with tight tangency.
Export as a CAD
like
file
a step or an eye just kind of thing.
Yeah. So out of Onshape, Parasolid is always going to be your best choice, just because we use the Parasolid kernel. Step is probably second to that, but Parasolid is always the best, right? One thing I'll mention too is just while we're talking about exports, I'm going to reverse this a little bit and talk about imports too. So a lot of times designs rely on imports, whether it's from surfaces from an ID team or something like that, right? Parasolid is going to be the best way in as well, because again, we're in the Parasolid kernel. One thing I have found in my experience of dealing with imported surfaces is you don't know how many times that it's been translated, right? And it's like an old VHS. Now I'm dating myself. It's like an old VHS tape, right? You're going to lose a little bit every time you do that. So when I'm working with surfacing, when I have to rely on like offsetting imported surfaces or leveraging imported surfaces, I will never trust the edges, because you'll end up, you might see the little segmented edges. So it looks like one edge, but it's 10 edges, right? So what I'll always do is I always do the thing of trust the face, not the edge. So what I'll actually do is I'll go in, I'll create a sketch, trim back that face to trust it, and then I'll rely on that new trimmed edge to either do a move boundary or do an offset once I have clean edges, right? So import's a little tricky in and out, but Parasol is always the best for file type.
Cool. We have one more, matching curvature when using sketch curves to generate. Why does the option of match tangent or curvature fail with sketch curves versus surfaces? You run into that.
I would say that's probably situational, right?
Yeah.
I'd have to see it. I would encourage a support ticket. So
Yep.
a support is another thing that you guys should leverage, especially because you can get to us right in there, right? I'm not on the support team, but we have an incredible support team. You can do it right inside. So when you're seeing this sketch issue, you can go right to that question mark drop down, contact support, and then share a screenshot, share the document with them. It is only shared with them, and they can get you some help. But we'd have to see the situation, right? And in general, I think curvature, the curvature relationship in sketches has worked. So
Perfect.
all right, I think we are a minute over, and we're not supposed to go over. So I'm going to end it there. Feel free. I think I don't know if they can still put in questions, but feel free to find me on LinkedIn or wherever if you have any questions. But thank you everyone for joining. I hope you enjoy the rest of the day with Onshape Live. I really appreciate it. I want to thank David as well for joining me and talking about his philosophies. So thank you all.
Thank you all.